I'm trying ordinary mirrors. I'm talking about the kind of mirrors you could get out of a copying machine or something of that nature, you know, a laser printer or whatever. Just broadband mirrors with a surface first coating on them, and that's what this is. It's real dirty right now. You'll have to excuse that. But I'm using a mirror like this one for the high reflector, which is just an ordinary glass surface first mirror. You have to use the side that has the reflective part on it. If you go to the other side, the CO2 laser beam itself will not go through glass. Glass is completely black to it, to the far infrared wavelengths that are involved. So if you look at this right here, you can't turn it this way or you'll just, burn the glass until it cracks. Well, there would be no laser beam in there anyway because it won't provide any feedback, not enough to do anything. This is the output coupler. And as you can see, as in one of my previous videos, it's just a surface first glass, just like this other one, except I've used a tile drill bit to drill a small hole in the center of it. And I made the mistake the first time of using silicone, and it wasn't completely dry when I put the salt on the front surface, and it seeped in there into the middle when I put the vacuum pump on it, and the laser beam actually started burning the silicone. It still gets kind of an incandescent glow to it because it's got silicone trapped in there, and the laser beam just cooks the silicone, makes it glow white incandescent just like it does its targets. But anyway, you can see that's the side that faces the inside of the laser, surface reflective part on the surface. On the other side, I have an ordinary piece of rock salt. Now I wanted to see how well this would work, and it does indeed work. And you see I replaced the silicone. I've still got silicone residue around the sides of it, around the edges of it here, but I replaced the silicone with JB Weld to seal the piece of rock salt crystal over that hole, and the little smudges around the edge, the little white smudges, are the silicone remains that are left over. But as you can see, that's just a piece of rock salt's all it is. And the reason it has to be rock salt is one of the few common materials, at least that I know of, that will actually transmit the thermal infrared wavelengths. We're talking about 10,600 nanometers as opposed to visible light that's between 400 and 700 nanometers. So it's one of the few materials that will actually transmit that long wavelength. It won't go through anything like plastic, plexiglass, glass. I mean, it's pretty bizarre stuff, which is really good because it allows it to actually better when it comes to processing types of materials that visible light lasers don't normally do. But anyway, rock salt window, that's about as simple as it gets. I mean, that's... We're getting down to a really scratchy made CO2 laser out of really basic materials when you're talking about just ordinary mirrors and rock salt. So then that's my goal here. I mean, for a real performance, you have to have a zinc selenide output coupler, and the kind of optics that would be used for a real laser. But it's pretty impressive to me nonetheless that something like this will work as good as it does. This is the rock salt. All I did was, it's just like ice cream rock salt. I just hunted through there till I found a piece that was nice and, straight, relatively flat on both sides, and stuck it on there. You could probably actually sand it smooth. Somebody was mentioning something to me the other day about this rock salt, and they said that, well, rock salt is all blurry. It's not clear, and so you probably got beams scattered all over the room, which that's why safety glasses are a must no matter what the conditions are, because the laser is extremely dangerous. But nevertheless, it does work all right. It works pretty good. I mean, the beam is obviously highly more divergent than it would be from a normal, using a real output coupler. But this laser is not going to perform like a laser using a real output coupler. The foggy appearance of the mirror is going to make the beam, the salt window is going to make the beam more divergent. Well, it's going to be more divergent anyway, but just a hole as an output coupler. But that's not really our purpose here. If you're an engineer, you're going to design something to be efficient, to be profitable, to perform well, and that's going to be your goal, so that you can manufacture something that works good and that a company can make money off of it. But for what I'm doing here, I'm just having fun. The idea here is just to see what I can get away with and what's possible. So I wanted to try just ordinary broadband mirrors. That was my purpose here, and rock salt for an output window and see what would happen. And this is one of the real output couplers. One of the real high reflectors for a CO2 laser. And as you can see, it's actually a gold-looking appearance. It's probably dielectric. I don't know. As you turn it to one side, you kind of get different colors to it. So I think it's actually dielectric. But anyway, that's an actual real high reflector for a laser, CO2 laser of this type. The other one I have is a kind of a purple color. It's really strange, and it's actually concave with a focal length of several meters. Yeah. But I actually get better performance with a flat high reflector, believe it or not. So this is a high reflector. Output coupler is an expensive item. It was donated to me because, and I don't have it here, but you can get extremely high power performance from one of these. That's my output coupler. As you can see, I JB welded it onto a separate washer that I use for the output window. See, it's reflective on this side, and you can actually see through it. Things look kind of yellow through it, and you're going to get very good performance with that because it transmits the wavelength very well. Does a good job of transmitting it, and at the same time, it reflects it just like the mirror would in a visible light laser. But as an alternative, when specific materials to the task are not available, it's good to know that you can build a laser out of almost nothing using broadband surface first mirrors and rock salt.